Hey all, it's Mrs. Gregerson. We are now working on lesson 7-1. This is where some of you are thinking, finally, we're in geometry mode. We have shapes. We're finding area. This is the stuff that we might even find slightly useful. Yes, it's true. Slightly more useful. Area is just simple. We use this a lot of time for, I always think of it like land development, building things, finding how to buy how much carpet for your house, painting, wallpaper, all that type of stuff. Area is important to know so you have enough material for things. I'm thankful that a lot of people use this. Carpenters are phenomenal at it. But we need to think a little bit more about perimeter. We're talking about area, volume. I'm going to go through this like you've already had this before because guess what? You have. So I'll be in a little more detail, but the first one is a postulate I want you guys to kind of emphasize on. It says the following. It's the area addition postulate. And basically it means sum of the parts equal the whole. What do I mean by this? What if you get a funky shape? Something that like maybe is a rectangle with a triangle on it and then maybe a semicircle. Now that's weird shape. To find the area altogether would be a real pain. But it's very doable if I break it into the rectangle, the triangle, and the semicircle. If I divide and conquer it, just kind of like you're battling in war, you'll be able to solve for those. So when I talk about area addition postulate, I hope you understand that means we can add up the different parts to get a larger figure. That's maybe a little bit more complicated. Another thing you need to remember is labeling. Labeling's huge when we talk about area. And if you go back to your grade school days, we always labeled it's basically how you learned what area was. Now length was really easy, we just figured how long it was, but when we put it in like a rectangle here, we would draw in these perfect squares. And when we talked about it, you would learn to count them and you'd get like, oh, that's 12. Well, 12 what? 12 squares, okay? So when I'm working with this area, we need to remember the label of area is in squares. And if there is no unit, we put units on there. So we'll say area is always going to be units, square units or square centimeters or square inches. So we are going to be really stickler on labeling right now too. Now, we are going to actually skip some of this little bit of stuff that you're doing. This is just talking about developing formulas for a parallelogram, and it's actually using rectangles to help us do that. A lot of you memorized that rectangles were length times width. We're not going to do that anymore because we already know from chapter 6 that all rectangles are parallelograms. So we're going to start with parallelograms, and you are required to memorize the formulas. Listen to me, you're not given the formulas 95% of the time on the ACT, so you have nothing but to memorize it yourself. So make sure you have that. So when we talk about the area of a parallelogram, we use the fact that it's called the base times the height. Now here's the key thing. The base is always a side. It doesn't matter which side. So there's your base. So here's our base from here to there. All right, so that's our base. And the height is the segment who is perpendicular to both sides or perpendicular to the lines containing both sides. So the height could very easily be right here. I could also draw the height on the outside, but notice where it stops. It's the same thing. So height could be inside, outside. It could be on like the length of a side, like with a rectangle. But the formula for the area of a parallelogram is always going to be base times height. Please do not use capital letters when you do these because those will mean something else later in a few chapters. So please make sure you use lowercase letters. So the area of a parallelogram is base times height. The area of a rectangle is the same thing, base times height. Some of you learned it as length times width, but think about that. Here's my rectangle. Can this side be my base? Right. Can this side be my height? Yeah. So length, that's the same thing as length and width. So we're always going to use the formula, even for rectangles, base times height. Now squares, we can do it a little bit differently than this. It is obviously it can be base times height. But another one that I like to use is the fact that we know the sides of a square are always the same. So your base and the height are the same thing. So we'll just call it S. So to find the area of a square, you could also go side squared. So that's another formula that you can have. But you don't have to use that because base times height always works too. This just is a time saver. Now, Let's go ahead and go to the other side page and let's work some formulas.